Okay, so this is going to be a continuation of 4.1 that we are working on today, and we've got some guided notes here. A blank copy of this will be posted in Classroom as well, or you can kind of write it down as I go. What I would recommend doing is printing out a copy of the video, or at least working on printing out a copy of the notes, or at least just working on them as we go. It's going to be very handy to have some graph paper. Don't necessarily need graph paper, but it will definitely save time when we're constructing these graphs. So today we're going to talk about graph and linear equations. Linear equations are equations that when I put them on a graph, they make a line. A blank, a linear, equation is an equation whose graph is a line. The points on the line are solutions. Solutions of the equation. A solution of an equation with two variables is an ordered pair. And don't worry, we're going to break that down, but I'm going to star that. Within a line, if I have a line, I'm just going to make a little line like this. If I have a line, there are an infinite number of points that lie on the line. And any point that lies on that line is going to be a solution of the equation that is represented by that line. In other words, when I plug in numbers for x and y, I am going to get a true statement, and we're going to look at that as it goes down here. First example, which ordered pair is a solution of this equation right here? Which is a solution? And I got to break down what we set up here. A solution of an equation with two variables is an ordered pair. So here's what we have here, and here's how I check to see if this point is a solution to this equation. Meaning, does this x and y, does this ordered pair, when I put it into this equation, substituting my x coordinate here and my y coordinate here, do I get a true statement? If that statement is true, then I know that it's a solution, and that ordered pair would be a pair that lines up, that actually lies on this line. So here's how we do it. Here is an x, and here is my y. And I am going to take this function, or this equation, this linear equation, and I will substitute in the 4 for x and the 2 for y. And I'll see if when the math comes out right, I'll have a true statement. So here's my function. I'm going to write it over here so we can see it. Y is equal to negative x subtract 2. You will take this x and substitute it in for that x. You will take this y and substitute it for that y in that equation. So I have this now. If y is 2, that's 2 then, is equal to negative x. X is 4, so it's a negative 4 subtract 2. Now I just do the math. 2 then equals negative 4 subtract 2 is negative 6. Now we just ask ourselves, does 2 equal negative 6? Does that give me a true statement? No, certainly not. 2 does not equal negative 6. This is false. When this happens, I can say not a solution. It's not a solution. Well, Mr. DeLong, what's not a solution? What that tells me when I get that false statement is, remember, this is a line. When I plug these points in, 4, 2, it is telling me that the ordered pair 4, 2 does not lie on the line. It's not a solution. Doesn't satisfy the equation. The ordered pair doesn't lie on the line. Let's look at letter B, 0, 0. Remember, that's at the origin. I still, though, have an X, and I still have a Y. I'm going to use this exact same equation over here, plugging in 0 for X and 0 for Y. Well, that's pretty easy to plug in. That would just be 0. That would be 0. So this is just 0 equals -2. Does 0 equal -2? No, it does not. This is not a solution, meaning the ordered pair 0, 0 does not lie on that line. This line, when graphed, does not go through the origin. This point doesn't lie on the line. It doesn't satisfy the equation. It's not a solution. We just take these points and we plug them in. X is -2, Y is 0. I will substitute these in. 0 then would equal, I have a -2. Remember, this is a -2. There's a minus here, there's a minus here. And then I have subtract 2. Now remember, when I have minus a negative, slash, slash, that becomes a positive. 0 then is equal to, what is +2 minus 2? Well, anything subtract itself is just going to be 0. Does 0 equal 0? Is that a true statement? It is true. It's true. And I can then say that the ordered pair, -2, 0, is a solution. And what did we say a solution is? It means that this ordered pair, -2, 0, lies on that line. It is one of these points over here that lies on the line. If I get ordered pairs that give me something over here, these are not solutions. They don't lie on that line. I'm just going to write that, which means it lies on the line. The ordered pair -2, 0 lies on this line. And it lies on this line because when I substitute X in for X and Y in for Y, and I do the math, I get a true statement. When I get that true statement, I know that that ordered pair is a solution and it lies on the line. We're now going to look at how we graph these. And the first way that we are going to learn how to graph is by making a table. Before we even make a table though, and this is why we did so many of these problems where we were solving for Y and getting Y by itself, because these equations, these linear equations, more times than not, we are going to be dealing with Y and X. Why do we deal with Y and X? Because that's how we graph. That's how our coordinate plane looks, is with a Y and an X. And I can get ordered pairs to plot points and graph this. We are graphing linear equations. When I graph this, these should make a line. If they don't make a line, a perfectly straight line with the same rate of change, I know I've done something wrong. First thing to always do, get Y by itself. If I look at this equation, this function, Y is already by itself. I would then construct a table exactly like this. I have my X here. I am going to write my function, or the math I'm going to be doing right here. My equation, Y is equal to X plus 1. And then, remember, solutions to the equation are going to be ordered pairs. So I'm going to get some ordered pairs over here, which I can then plot on my coordinate plane, connect my dots, and I should have a line. Well, what values do I use for x? What are we doing here? Well, we're really trying to get ordered pairs so I can connect the dots to see if it makes a line. It should make a line. Biggest question here, what ordered pairs do I get? In the rationale by the numbers that I am going to choose here, I'm going to show you what I'm going to choose. And I'm always going to pretty much go in this order. I'm going to use -2. I'm going to use -1. I will use 0. And I will use +1. And I will use +2. Why did I just pick those points? Well, I picked those points because if I look, if x is -2, that's going to give me what's happening with this line over here. -1 will give me what's happening over here. 0 is going to be right at the origin, what happens at the y-axis. And then I've got some positive numbers over here. It's going to give me a look in all 4 quadrants of what's happening. If I just stick to numbers over here, well, it's only going to give me points over here. I want to choose points that are on both sides of the origin and the origin itself. Not the origin, but when my x is 0, where it crosses the y-axis. So if I have x's, I can certainly get y's. Here's what the value of x is. I'm going to simply take that x, substitute it into my equation or my function here, and then I can get a value for y. That x and whatever y I get is my ordered pair. So here we go. If x is -2, this is -2 plus 1. What is -2 plus 1? Well, -2 plus 1 is a -1. That's what y equals. I can certainly write my y equals there. Once I have an x and I have a y, I now have an ordered pair of -2, -1. I'm going to do the same thing for each of these values of x. I'm not going to write my y here because I am lazy, but that is going to be -1 plus 1. Well, -1 plus 1, or if I just add in the opposite of itself, that's going to be 0. And now I have the ordered pair -1, 0. If I plug in 0 for x, this is 0 plus 1. That gives me 1. So I have the ordered pair 0, 1 now. I'm going to plug in 1 for x here. 1 plus 1. 1 plus 1 is 2. I have the ordered pair, an x of 1, a y of 2. I can plug in 2. 2 plus 1 is 3. I have the ordered pair of an x of 2 and a y of 3. Now I've got 5 points that I can plot, and it's going to give me a good look at what this line looks like, if I did my math correctly. And I want you to notice something here. Hopefully you see a pattern developing in these y's. How do I get from -1 to 0? I would add 1. How do I get from 0 to 1? I would add 1. 1 to 2, add 1. 2 to 3, add 1. If I were to put 3 here, hopefully you wouldn't have to even do the math. You could tell me that this is going to be 4. When my x's are changing by the same number, my x's are actually increasing by 1. If this is a line, you are going to have a constant rate of change. You are going to have y's that are going to follow a pattern. Let's plot these points. -2, -1. To the left 2, down 1. That's that point right there. -1, 0. To the left 1, up 0. Again, paying attention. I know if my y is 0, it's where it's telling me it crosses the x-axis. Right here at -1. I'm at 0, 1. And I can see that these are starting to form a nice little pattern of a line here. 1, 2. Right there. 2, 3. And this is going to hold the same pattern in both directions. I don't even have to do the math on those. I know because these are correct, it's going to have this slope, this constant rate of change. I will take my straight edge here, which I'm using a protractor today. I'm going to connect my dots. I am making a line here. So I am putting arrows on the end of my line to indicate that this line continues on in both directions to infinity. The line just doesn't stop, it keeps going. Let's look at another one here. I'm going to flip my notes over. And we are going to look at this one. First thing it says on the front page, is y by itself? Well, it is by itself in this one again. Y is already isolated. There's no numbers, no coefficients out in front of the y. It's already by itself. I'm going to write my function here. Y is equal to a -2x plus 1. Again, I'm going to pick some points. And again, I'm looking at this right here. I'm going to pick some points to the left of the origin and to the right of the origin for x. That's going to give me a good look of what's happening to this line. Maybe it's going this way, maybe it's going this way. I will choose the same points that I did last time. This is -2, -1, 0, 1, and 2. And now I'm just going to plug these in. But now I got to be careful. X is there. This is what x equals. So now I'm going to have to multiply by -2, whatever x is, and then add 1. So this one is -2 times -2 plus 1. I'm going to go through and fill all these in this time. I'm going to have -2. Now it's going to become -1 plus 1. I'm going to have -2 times 0 plus 1. I will have -2 times 1 plus 1. And I will have a -2 times a +2 plus 1. I just simply substituted these in again for x in the function or equation that I was given. Now I'm looking to get out, when x is -2, what's my y? Well, I'm just going to do the math. -2 times -2, +4, plus 1 is 5. Negative times a negative, -2 times -1, +2 plus 1 is 3. And again, I'm already starting to see a little pattern develop here. I can't tell with 2, maybe I did made a little mistake here. I can see that these are going up by 1s again. This looks like it's going up by 2, or going down by 2s. 5 minus 3 is 2. So if I'm going down 2, this one might be 3 minus 2. This one could possibly be 1. And if I look right here, that's going to be 0. It is 1. -2 times 1. -2 plus 1 is -1. And again, I'm going down by 2s. 2 less than -1 is going to be -3. -4 plus 1 is -3. You now have these ordered pairs that you can now write. So here we go. This is the ordered pair -2, 5. This is -1, 3. This is 0, 1. This is 1, negative 1. And this is 2, negative 3. I've got some points. I can certainly plot these over here in my XY coordinate plane, and I'm hoping that they are going to make a line. Negative 2, positive 5. Negative 2, positive 5. Negative 1, positive 3. I'm liking what I see so far. 0, 1. And again, when x is 0, it tells me where this crosses the y-axis. Anything that lies on this y-axis will always have an x-coordinate of 0. 1, negative 1, look at that. 2, negative 3, and it holds that pattern in both directions. It looks like a nice straight line. I am going to take my straight edge, ruler, protractor, side of a book, whatever you want to use, construct my line, put some arrows on the end, and I've got that line. Just like that. Last thing we are going to look at today is what happens when I just have a y equals or a graph that is x equals. The graph of y equals negative 3 is a horizontal line that passes through. Now if it hits the y-axis, if y is negative 3, it is always going to have that x-coordinate of 0. The line y equals is a horizontal line, goes left or right, passing through this graph at y equals negative 3. 1, 2, 3. That's the ordered pair, 0, negative 3. It is a horizontal line that passes through negative 3. And I notice here, if I made a little XY table here to get my ordered pairs, it doesn't matter what the value of x is. I could put in negative 2, negative 1, 0, 1, and 2 again. You don't see an x in this equation, but there's an x here. This is telling you is y is always negative 3. And look at these points that are here. If y is always negative 3, it doesn't really matter what my x is. My x, when I go out in both directions, is always going to give me a y value of negative 3. That's what it means. We need to memorize this. Think of this any way possibly you can. But the line y equals is a horizontal line passing through the point of 0, negative 3 on the y-axis. On the flip side of that, I have something that is x equals 2. The graph of x equals 2 is a vertical line that passes through the point 2, 0. To the right 2, up 0. It passes through that point, and it is a vertical line passing through that point. And again, if you made a little XY table, if x is always 2, sure, my y is going to change, but your x is always going to be 2. This is the point 2, 0. Now, 2, this would be the point 2, 1. This would be the point 2, 2, 2, 3, 2, 4. This would be 2, negative 1, 2, negative 2, 2, negative 3. Your y is going to change, but your x is always going to be the same, and that makes a vertical line. We are definitely going to dive into more of this as we go on. but this is a good start.